We are streaming. Time to open up. We got LADR opened up. Let's open up Emacs. All right, first things first. Let's load a theme for the day. Load theme. What's IOSCVM? That looks kind of nice. I'll have to see what the cock files look like. Open up classes.v. Okay, this is pretty cool. It's okay. I think we can do better. We did our Acario Dark, I think, last time. What's Dark Plus? Nah, I don't like Dark Plus. It's not great. Challenger Deep. Okay, here, let's do this for a while. A little bigger. All right, let's see. So last time we wrote the vector space we wrote the vector space class, which I'm really proud of. We did some scoping, some notation. I hope that continues to work out fairly well. And then I did a lot of admitted. So we're going to have to figure out these proofs, and they're going to take some auxiliary lemmas, and that's what I'm going to spend today doing. I'm going to try to actually knock out proofs this time. Last time there wasn't a lot of proving. I didn't do a lot of proving, but we'll get started. So the additive identity is unique. Let's go back up in the book to where this was declared. Unique additive inverse. Every element in a vector space has a unique additive inverse. So the way to express that, do you think this is the best way to express that? Well, first of all, let me do it with my notation. So I'm going to here. Sometimes it doesn't. Like I need to. open up another cock file. Before it'll let me do notations. Hey, what's up, viewer? Good to see you. Thanks for coming on to the stream. Dot plus. Undefined token? Maybe it's plus dot. It's plus dot. Yeah, it works well with the notation. That's good. Okay, so if V plus RA inverse of V times V, RA inverse of R1 times V, R1 being the one from the ring, oh, I did this wrong. I didn't set this up right. Suppose V is a vector space. You all right there? I got a dog here. Maybe I'll show him to you a little later. He's just sneezing and coughing right now, but he's okay. So for every V, for all W prime of type V, for all hypotheses H, that V plus W equals V0, and HW prime W equals W prime. That's because I did the wrong plus. Okay. So a way we can do this is we have HW is defined to be V plus W equals 0, and HW prime is defined to be V plus W prime equals 0. If we can, there's a few different things we can do. if we can do this lemma, subtract from, hey, 4 viewers, how's everybody doing? Let me know in the chat. From both sides is of type for all VU in V, V plus W equals 0 implies W. Well, it's really VUW. I'm going to go back here. For every VUW in V, V plus U equals W implies U equals W minus V. That would take some proving. But I think it could be done. Oh, and then what you can do is you can do subs. If you call subs on these, you should get V plus W equals W. V plus W prime. And if you can introduce some notion of subtracting from both sides, then you get the goal. So what we really want is we want to be able to subtract from both sides. And this can be that the function like plus V is injective. Because that means we can, if f is like the function, if f equals lambda w arrow v plus w, and injective of f, then v plus w equals v plus u implies w equals u. So what we really want to do is show that a unary addition by partially applying addition with v is injective. So let me try that. For every v, for all uw in v, v plus dot u equals v plus dot w implies u equals w. You can strip out the v plus because of injectivity. And let's just say we have this admitted for now. Rewrite HW prime in HW. Oh, let me make my my goal bigger. And then apply addition injective in HW, apply HW. We're done. So that actually won the game. Just if I do print assumptions, it'll show me that addition injective is an axiom. It's an axiom because I didn't prove it. So let's see how we would prove this. Proving it at the type class level is going to be very difficult. Jeez, I do not know how to do this. I do not know how to do this at all. I don't know the first thing about how to prove this. Bum, 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 bum. Bum, bum, ba-da-da-da. Bum, bum, bum. Bum, bum, ba-da-da-da. All right, we basically prove that point. If we have injectivity, then we have a proof of what we were looking for. Now, in order to get injectivity, we have V plus W equals V plus U implies W equals U. So there's a couple different ways we can do this. Is if we can apply a function to both sides. Do minus let me just look at the book one more time to see if it gives me any ideas. Right, like what happens if I compute in H2? Unfold addition in H2? Yeah, that's not very nice. It doesn't really do anything. Proving things at the type class level, people. That's what we're doing. We're proving stuff at the type class level. We need a notion of subtracting from both sides, of applying a function to both sides, which is never as easy as I think it should be in Coq, to be honest. Cancel additive. let's say VW, UV are of type V. V equals W implies V of addition minus dot V equals W minus dot V. So this is the subtracting V from both sides. Switch this to U, switch this to U, switch this to V. No. Switch this to U. This is not provable. This should be provable because it's just function application. Subst reflexivity. Apply cancel additive in H2, and we get not quite what I wanted. Not quite what I wanted. I have to be more careful. The canceling additive worked great, though. UVW. Cancel additive 2. What this is going to be, this is going to be U plus V equals W. Implies U equals V plus dot minus dot V. Plus dot. Ah! Now we come to associativity. So it's not even a theorem. So last time I copied out all of the theorems about vector spaces in here, and it's not even associativity of addition is not even one of them. Um, that's okay. Lemma. Oh no, I have no clue how to prove this. This is a proof by induction when you're doing plus over nat, but you can't induce over. Ugh. Excuse me. Let me check if there's anyone in chat just not showing up on my phone. Nope, no one in chat. Not apply, rewrite. There you go. Now all we need is that v plus additive inverse of v is 0, which we don't have yet. And that u plus 0 is u. Okay. Well, we never proved this. I can't believe we never proved this. What about unique additive identity? Oh, I forgot to write down 0 unique. Oh no, there's 0 unique. Oh, and I already proved it. Well, I proved it with. Oh, you've got to be kidding me. You've got to be joking me. I totally screwed this up. This is unique additive inverse. I need to do unique additive identity. Vaditive. V minus V equals Z prime, then Z prime equals V naught. Admitted. Unbelievable. That V additive inverse. Unfold V additive inverse. What if some of these have to be an axiom? That's quitter talk. That's quitter talk right there. I wonder what happens if you like. Oh. Oh. Oh, now we're talking, baby. Now we're talking. No, but I don't have a proof that V addition equals V addition. V addition 0 equals V addition. That sucks. What if I just do destruct H1? Same thing. Bam, bam, bam. Destruct as that is so frustrating. I literally need to assert that V1 equals V naught. Generalized dependent H naught. That never goes away. This is awful. The hypothesis unpacks into something that doesn't even match the names. So, like, I could construct a proof. I could construct this proof. Ready? Destruct h1. Destruct is vector space 0. Destruct A as, well, this is going to be H23, H24, H25, H26, H27. Maybe I did too many. Oh no! So I can't prove that Vedition 0 equals Vedition. I can't. So associativity is not something that I'm going to prove up here. Well, I mean, it might be. It might be easier. I've got to figure out how to. Let's try some of these other proofs. Oh, so now it is v addition 0. H22 at UV minus dot V. V additive. So unfold V additive inverse. Specialize H24 at RAINV R1 star V. I need more parens. Destruct H24 as WH24. Crap. All right, if we're going to play hardball, I'm going to need a cup of coffee. Gerhard, how's it going? Thanks for coming back to the stream. We're having a good time here. I'm proving stuff at the type class level. Where are we stuck to? I resent that assumption that I'm stuck. Come on. No, that's okay. I'm just kidding. Of course I'm stuck. What do you think this is? This is the Linear Algebra Done Right stream, where we get stuck. We're doing all proofs today, and I'm leaving right at 5 because I got stuff to do. But 5 Eastern. But we're trying to prove stuff at the type level. So let me catch you up where we are. For instance, this is just an extra lemma that I need for one of these properties. It's like unique additive identity or something. I need this extra lemma. So what I'm doing is I'm literally unfolding the hypothesis that V forms a vector space to get the vector space theory, right? So since I have in my hypothesis space that V is a vector space, I have all of these hypotheses. So I'm trying to use them. Yeah, we're proving stuff at the type class level. That's what's going on. So sorry about those proofs you were interested in last time. They were just at like the instance level, so like I wasn't interested in finishing them. And I still haven't finished them. And I won't be able to because I've restructured all the files, so I won't be able to until I figure out like relative imports and all that stuff. But I'm just trying to prove as much as I can at the type level. So what I'm having trouble with is the fact that sometimes what it looks like it's doing is it's unfolding a different like addition operator from the hypothesis than the one that's in the goal, which is a huge pain. And I can't be sure that like the scalar mult that's represented by this star is the same as this scalar mult here. And V1 is actually a 0. In the V1 in the hypothesis is actually behaved as a 0. I need to apply commutativity is what I need to do. Apply H21 at V and RAINV R1 star V. Not apply, but rewrite. So the problem there is I had an exists. I got stuck because I had an exist in the hypothesis, an exist in the context, which I destructed. But what I needed to do was find a way to assert W equals V, which isn't going to be possible. But if I have assert W equals V, and I have subs H2. Then I can rewrite H24. Apparently I can't. Well, let's get rid of this assertion that's a false. Um, there's a whole project of just unpacking all of these and making them top level lemmas. So instead of being things that you need to descend into the hypothesis for making them top level lemmas, it's going to be really tricky. We're doing it though. All right, let's rearrange some of this a little bit. For all x, there exists a w such that x plus w equals 0. So I really want to specialize H24. What I really want to do is specialize H24 at V and find some way to prove that w equals minus V, which I have no idea how I would prove that. And there's some notion of V1 being the same as V0. Yeah, what I want to do is I want to show that, yo, it's not on GitHub. I know. Here, let me do that right now. Um, Get init, get status, get add dot, get commit, first commit. All right, I was gonna. Yeah, it's not on GitHub yet. I'm gonna do that right now though. I guess I'll do GitHub. I was gonna do GitLab, but I'm trying to do like all of my trash and my notes on GitHub and all of my serious stuff on GitLab. But like until this is serious, I'm just gonna put it on GitHub. And when it gets to be like really serious, it's gonna be LADR, linear algebra done right in Coq. It's searching through to make sure it's available. Git remote add add origin. It's going awful. Just the pasting and the terminal and Emacs. Authentication failed. I didn't type my password very well. Authentication failed again. I don't know my password. What's wrong with my password? It might be something else. I'm going to try one more thing. Sorry about this. But it's good to get this on GitHub because this is like what, week 3? Unbelievable. I'm going to have to off stream sometime get my password. Here, I'm going to give up for now and get back to the proof. Sorry it's not on GitHub yet. Thanks. Okay, so H23 as V naught prime H23. And we'll ultimately specialize H23 at U for X. But we can do, but that comes later. My problem is what I need to do is I need to show that minus V prime equals minus dot V. But let me just walk you through, Gerhard, because you can't read on GitHub. Some of the stuff you might have missed last time is after I have the vector space type class, and the vector space theory is all of the axioms of vector spaces. I open scope. I give context where f and v are types, and f and v always are a field in a vector space. And I gave some notations. So the additive inverse on vector spaces is the minus dot, and the the addition on vector spaces is the plus dot, and they're scope to vector space scope. Now this I'm certain I have no way to prove that minus v equals v. But now we have a problem. We have the same problem. See, that shouldn't work. Specialize H23 at U. Rewrite H21 at U V1. Assert G prime is that v naught prime equals v1, which is just that our system is generating more zeros for us. It's generating more zeros than it should, I think. Give up, because that's not possible. And then rewrite g naught prime. And then you have a simple case of rewrite h23. And then you have reflexivity. That's the question, Gerhard. That is exactly the frustration. So what's happening is if you look at what's happening, if I destruct H1, so H1 is the hypothesis that F and V form a vector space. If I destruct it, it doesn't pull out, it pulls out a hypothesis that V addition 0 is a V arrow V operator, right? What it doesn't do is it doesn't point, hey, V addition. I'm still figuring that out. I'm figuring out how when you pull information out of a type class in your if your hypothesis is that something satisfies a type class, and then you pull information out of it, and it does some renaming stuff that I don't understand. But then it doesn't. Like, it translates, like, watch this. If I do locate plus dot, I'm just going to show you this one thing that I'm going to do that. Locate plus dot, it's V addition. It says V addition, right? But when I simplify on plus dot, it turns into V addition 0. So paste the text file in pastebin. Yeah, I'll do that. I'll do that for you. That's a good idea. Or better yet, jscock.github.io/scratchpad. I gave a talk last night on like intro to cock. Oh, come on. Now my Wi-Fi is acting up. My browser, it's my browser. It's not my Wi-Fi. Oh, tell me it's going to have cock. Nope, it doesn't. That's okay, because here, I gave a talk last night in this. Oh, wait, no, I can't send it to you. I need to send it to you via pastebin. All right, let me know if this works. Let me know if this works. And we'll see. Oh, it looks like there's a lot of lag here. It looks like there's a lot of lag, because this is still not caught up. And I'm jumping around in the screen, so... okay, cool. Yeah, and you can go to jscock.github.io/scratchpad to anyway, where was I? All right, so let me do a quick exercise. Here's the exercise I want to do now. Is I want to start converting information that's from the information that is from the type class hypothesis and convert it to top level lemma information. That's what I want to start doing. So what I do is I destruct h1. I destruct is vector space 0 as... In fact, what I'm going to do is I'm going to do a tactic. LTAC unpack vector space h1 is defined as destruct h1 There you go. Yeah, so we're going to have to be writing tactics at a certain point. And this is just apply h22. Maybe it's symmetry and then apply h22. Yeah, then let me factor out the need to write symmetry just to keep it uniform. Yeah, so that's addition of soap. What we have done is we have pulled it out from we can prove stuff using associativity without diving into the type class, which is great. And we should do that with everything. The addition commutative. LTAC, release information, H1. Release information, H1. Crap. Oh well. QED. Huh. Oh yeah. Plus dot. Unpack vector space H1. Simple. See, this is where it actually gets non-trivial. There exists a zero such that for all v. That's the correct order of the quantifiers. The problem with that ordering of the quantifiers is all I can do is destruct H23 as V naught prime H23. Specialize H23 at V. Oh, you know what? This is not, there exists. This is not an exist. This is supplied. This is not, Garrett, you gotta check this out. I did a quantifier up here because I was just reading off mindlessly. But 0 is supplied as an argument at runtime. So it's not an existence proof at compile time. Holy crap. And I'm going to make this... I have never seen that before. I thought it was an existence at compile time, but since the existence of the thing is guaranteed by the caller of the function, the caller is obligated to provide the thing that exists. That means I don't write it as an existence. That's what you were asking about before? Well, I had to figure it out the hard way. I couldn't just take your advice because I am an idiot, alright? This is the dumbass linear algebra done right in cock stream. It is a stream. It is a dumbass stream. That's what it is. Lemma inverse. I think I do exists. That was a brilliant distinction between. That was brilliant. I learned so much today. Let me just sit on that a little bit longer, and then I'm gonna make a little coffee. Since the caller supplied the 0, there didn't need to be an existence at compile time. But an existence obligation at compile time is like totally different from a runtime obligation. That is deep. That is very profound, and I will be right back. Give me 1 second. That was exciting. A compile time obligation means that I don't do something that leads with an existence. Well, at least not for the case of 0. Easy. Release information H1. These are all one-line proofs. But Vedition inverse means there exists a W such that V plus dot W equals V naught. And this is going to be different. This is going to be exists. Well, first let me what's this? It's going to be specialize H24 at V. It's going to be destruct H24 as W H24. And it's going to be exist W. Simple. Apply H24. QED. Easy. Give it literally 5 more seconds. You can instead maybe prove something like for all Z, for all hypotheses that Z, if you want to retain the existing. Oh, I don't want to retain the existing. Lemma v multiplicative identity. R1 times V equals V. Unpack vector space H1. Apply H25. Release. I need a better name for this tactic. and distributive 1. But yeah, that would be, hopefully that would even be provable if I went that route. That's an interesting point. That is an interesting point. And we might end up playing with stuff like that later on today. So V distributive, this is going to be A times U plus dot V equals A times U plus dot A times V. And I think I can kill the parentheses and it'll compile perfectly fine. By definition, it's better. It is better. But it's only by definition for vector spaces. So I'm going to call it V by definition. Because it's not as general purpose as like a tactic named by definition would be. Like a tactic named by definition would be like scary, like how general purpose it would be. Deflate, how's it going? Good to see you. Thanks for coming on to the stream. I sent Gerard a paste bin. I couldn't find my GitHub password for some reason, but I don't want to go into my password manager like on stream. But oh, it probably does. Oh, it does. It totally does. I'm just like not. I told you this is an idiot stream. Okay, this is a dumbass stream. I told you, like, this is not. I am not like a large brained person. If I was a large brained person, I would have done that. I would have done like I forget what the pattern is, but like I know evil Emacs. Okay, I know Vim. I know some Vim. This is a Vim Emacs mode, by the way. I'm not that happy with the theme for the day. I'm glad I'm only using this theme for one day, like, because I'm not that crazy about it. Yeah, there's probably look if y'all want some good Vim magic, maybe go to a different stream because look, if it takes me longer to think about it than to do it, I'm just gonna do it. Okay. I mean, this was an instance where it didn't take me longer to think about it than it did to do it. Sometimes I need to do it because it's like more tedious. But this wasn't that tedious. This wasn't that bad. this is going to be radd AB. Unless I have it in a field notation, which I think I do. So let me go back up to my notations. Or as my Emacs people would say, search for radd. Yeah, plus is in field scope. I can't believe I had to make my own field scope. That's probably not good. It's probably not a good sign. Yeah, it doesn't like that. Oh, wait, it doesn't plus dot. Okay, so now we have lifted. So Matt, what we did was we had all this information that was hiding in the we had all this information hiding inside the type class hypothesis. If you have a hypothesis that like V is a vector space, then that means you can unfold all of these as basically axioms. So like the problem was it's stuff that it's shit that's like hiding, you know? So what I wanted to do was I just made all of these axioms as theorems that go down to the vector space definition. So I'm going to comment this out because I might not even want it anymore. Cancel the additive too. And it has some issues. I would need to go back to it, and it might not be the most interesting thing anyway. So let me just remind myself where I'm at and what needs doing. We need to declare the uniqueness of additive identity. If we need to get V minus V equals V naught, which should be trivial. Can't they be separate fields? So that's an interesting question. I'm just going by field theory and ring theory, which are in the standard library. So basically, here's what I did. This was last time. Check field theory is a function from all these things into prop. And if you supply these arguments, what you'll get is a conjunction. I don't know what you mean by separate fields, though. I guess I don't know what you mean by separate fields. So what I did was I made a vector space theory that behaves exactly like field theory behaves, which is a function from the elements that make up the vector space, the addition, the scalar multiplication, the zero, and I just made a conjunction. I don't know if there's a smarter way than... Sorry. I just put a foot on a dog. There's a dog visiting my house, by the way, this weekend. Maybe we'll see the dog later. He looks ridiculous. Unique v additive identity. So yeah, back to this. Like fields of a type class. Because I wanted to use the field theory function from the standard library, because when you prove field theory of 0, 1 plus mults inv blah blah blah, then you can do this awesome. So if I have an instance, add field, my field proof that my field is field dot. And when I do that, it goes into a database that unlocks a bunch of tactics. So that's the direction I want to go in, and I want my type class schema to help us head in that direction. But it's a good question. It would make a much more complicated looking type class, is the thing. And since I'm hiding this, like, destruct is vector space as this annoyance, like, that's annoying to read. I give you that, right? But I'm hiding it behind a tactic, so I don't really care. What is that tactic called? Unpack vector space. But I don't want to unpack the vector space. I want to use my lemmas. It's Vedition inverse. So what I want to do is okay, what I'm figuring out is how to use this Vedition inverse. I'm figuring out how to use Vedition inverse to do this. But the way there's their existence in there, so what I need to do is I need to assert G Vedition inverse V. Or it's like, I always forget. I'm getting my types screwed up. My sorts screwed up, rather. Like, Vedition inverse is a prop, right? Vedition inverse of V. That's a prop. Well, it's not a prop. It's a proposition of type prop, but Vedition inverse V is, so you know what the best thing to do is to do assert G exists W V plus dot W equals V naught. And in that proof, apply Vedition inverse V. Oh, no, 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 no. That's bad. That is bad. Using inductive instead of definition and replacing conjunction with arrows? Oh. I did briefly think about replacing conjunction with arrows. I just don't know if that's not how field theory is made though. Well, here's the thing is I looked at the standard library, the only thing I could find on field theory was actually a record. It was actually a record, and records are products and products are conjunctions. So it wouldn't match the pattern that's in the standard library. I feel like doing that, what you just said, makes it less match the pattern in the standard library. Records are built with inductive though. Um, I don't. I don't know. I don't know about that. I don't think they are. I think records are built with record, and record is a wrapper around product. I think I just remembered this. A record is a macro that converts into inductive. See, I thought a record was a macro that converted into product, but I guess it would be the same thing. Yeah, no, that's what this is saying. Although records are not part of this core, Coq does provide some simple syntactic sugar for defining records. Record types must be declared before they are used. Internally, this declaration is desugared into a single field inductive type like this. Yep. So you're right. You're right. Use inductive instead of definition. I see what you're saying. What works? What did you just get to work on JS Coq? Oh, change it to inductive? Well, what it should do is it should follow the standard library. I just got confused last time I looked at the standard library. So this is what it looks like. Like all I'm convinced of, all I'm convinced of is well, it might be something that changes up some of the code, and I would rather do it sooner rather than later. I'm more convinced that that it should be a record and let the sugaring, the desugaring, change it into inductive than I am that it should be, I should just go straight to inductive. I'm more convinced that it should be a record. I need to show that V equals minus I need to show that W equals minus V. Maybe I don't even want to do subst. V naught prime, V naught prime, V naught prime. Yeah, whether or not I do subst doesn't really matter. So I translated this into my own expression of uniqueness. I thought through my own expression of uniqueness, and I didn't actually express it the same way that he did. What are some other ways to express uniqueness? I'm going back up to my injectivity attempt. What are some other ways to express uniqueness? For every V, and if I could copy his proof, that would be cool. You should probably use the definition of the additive identity to specify uniqueness. Yeah, so if I have, for every V of type V, for every H of type, for all U plus dot V naught prime equals U, I need to put U and I need to put V naught prime over here again. V naught prime equals V naught. V naught is the official name of 0. Error H is already used. Is this what you had in mind? This is a good idea. I like this idea a lot. It's a little strange to use the one you're using with the whole x minus x thing, since that's not really the definition of V naught. Of course it's the definition of V naught. Wait a minute. What's the definition? No! You're right. The definition of V naught comes from a different axiom. The definition of inverses is derived from the definition of V naught. Is derived from V naught, but you define V naught first. I mean, like, this doesn't really say anything about the order. You know, like, in dependent type theory, like, everything's dependent on what came before. So, like, the order in which these axioms happen, like, really matters. There exists an element, you start there, and then you do additive inverse. You're 100% right. You are 200% right. We don't need to intros anything. Specialized H2 at V naught. Subst. Oh, yeah, this is doable. This is 100% doable. Rewrite H2. And then search Vedition. Vedition ident. Well, I need to do commute first. Gerhard! You did it! Yeah. Yeah, I basically copied the proof from Axler. That was all you, though. That was all you. That was not me. I just make the keys go clack clack, okay? I don't really know how any of this stuff works. If we're being honestly real here. This is awesome. I am so satisfied with that. That is such a satisfying proof. I am the showrunner. That's true. Yeah. What? Oh, I don't actually know what you mean by that. Oh, we are having a good time. So I wonder if I want to prove this as a lemma, not as a theorem, but as a lemma. Thank you, Gerhard, for your support, for always watching the stream, and for your ideas, and then telling me I'm the showrunner. Thank you. I wonder if I want to attempt... I'm going to leave this here just in case I come back to it. So if I have a proof of that the addition is injective, so this is what I was doing when I first got here. I think this was before people showed up. Is I want to show that for every v, the function lambda u v plus u is injective. Cancel v additive 1 is proven, but it didn't help. This is just subtracting v from both sides. Oh, but I need to do lemma, add v to both sides. For all v, if u equals, for all w, if u equals v, then w plus dot u equals w plus dot v. And let's just say it's admitted for now. Apply, what the hell did I just call that thing I just defined? Add v to both sides. That's a terrible name. It's actually a great name. Terrible or great? Unable to apply a lemma of type to hypothesis of type. No, it's cancel v additive. Oh. Here, you know what I'm going to do? I'm going to do this. Huh. Look at that. That's not even an E rewrite. All right, I need a better name for add v to both sides. I need a better name, but for now, this is good. I mean, it's going to be really difficult to prove this. That was easy. Okay, so the beginning of it wasn't difficult. What about the other direction? I want to take H2 and subtract W from both sides of it. I was thinking that. That was one of the things that was in my head that was like a preformed thought that like I hadn't said out loud. But I know what you mean. That is brilliant. That is so brilliant. I love it. Lemma. Okay, fine. We need a better name, y'all. That was a brilliant call. I was gonna get there in a sec. I was like, I was gonna get there, I think. Uh-oh. No, that went in the opposite direction. That went in the opposite direction to what I wanted. Oh, wait. No, I want to add RAM times W. Yep, that's what I want to add. No. I am so dumb. Oh my goodness. Boom. This is nice. Now we do some assoc. Yo, someday I'm going to be writing tactics. I'm going to write a tactic where you just type vector space and it just kills this. Is it Venetian inverse? It's not Venetian inverse. This is painful. Why don't I have... I just never created v minus v equals 0 yet. I just haven't created v minus v equals 0. Okay. It's strange that it's not there. Oh, that's a good strategy. That's a good strategy. That is a really good strategy. Which distributive property? It's v distributive 2, right? Yeah. What are you talking about? That is a brilliant idea. All right, Deflate. See you later. Thanks for coming by. I only have a half hour left this week. Oh, I know why. Yeah, it's not going to let me do it until I figure this out. I have to figure out how to rewrite it exactly once. rewrite in one place, cock. It's not generalized rewriting. Replace? I don't know replace. It's not on PJ Reddy's tactic index. Yeah, but V with... It's the same problem. I'm trying to rewrite it like at 1. Oh, that works. At 1 works. Now, does this work? It also works. You can do at 1 with rewrite instead. So it's much better. That sounds complicated. It sounds interesting, though. Maybe I should do it just to stretch my boundaries. Oh, no, everybody. At 1 is cooler. But I want to try what you're saying, because I don't want to do the next thing I have to do. Yeah. Okay. Look at that. Y'all. The destruction works. I better be able to rewrite with this eek. It's R op def. Whoa there. Whoa, Nelly. Settled rewrite failed. This is nuts. Apply our eco. V multiplicative identity. Oh, no, that applies for R1. I still need to struct ring, I know. Well, would I? Hold on, this is an exercise, actually. This is an exercise that's at the end of this section at the end of section 1B, and I wrote it down as an admitted lemma. But this is where we would destruct ring. And then here, R naught times V equals V naught. Zero times vector. So what I wanted to do was I wanted to destruct ring only up here. The only problem is r equals 0 and eq. That's literally the only problem, is I can't do a rewrite. Because R equality is like a special thing. But here's the thing: is it's replacing everything from the goal in terms of these new destructed names. It's replacing automatically, so it should replace the equality relation too, because all I did was I passed in. Let's take a look at the ring type class. Oh, R-eq. You know what? You know what I want to do? Look what I did. For field eq, I didn't even pass in the same eq. So you know what? I'm going to be consistent. What the hell? Why is Vim not working the way Vim should be working? Oh, because I was still in search mode, that's why. Yeah, I'm not going to have it pass in a special equality. I'm only going to have it pass in eq automatically. That might be I might be losing generality in a way that's going to kill me. I don't understand why field and ring you pass in these special equality operators. I couldn't do apply req 0, req 0. Like it didn't make it. It wouldn't have made sense. I am never going to get to subspaces. It could be weeks before I get to subspaces because I want to actually clean all this up. Why does escape bring me up here? Oh, because it still thinks it was searching for W's for some reason. Now this I might end up destructing ring again. This is an exercise. It's not an exercise. It's given right here. Okay. So let's do... I still need to destruct ring. So let me do... I'll put this at the top later, but ltac unpack ring H. Destruct H. Destruct is ring 0. That's weird. How did I do... What? Why did it let me do that? And it works with inversion, but not with... Rewrite radd 0L with R naught. And then this is going to be rewrite v distributive 2 depends on variable h naught, which is not declared in the context. because I destructed it. That's a huge problem. That is a tremendous problem. I mean, the hypothesis that H is a ring is still there. Coming up to the last 10 minutes. I gotta go right at 5 today. I might go in the next 5 minutes because this is. I don't know if I'm going to make progress on this. But here's what I don't understand. H naught is declared in context. It's just not declared before the R starts unpacking. All right, we had a good 3 hours. We had a good run, but it's either at view both sides 1 or 2. Probably 1. Wait a minute. No. You replicated some proofs in the book today. Good for you. That's awesome. I'm glad you're following along here. Maybe when I go to GitHub, you can like send pull requests and stuff if you're interested. I don't know. Maybe we shouldn't go down that road. Maybe that would make it too complicated. All right, everybody. Oh, thanks for coming to the stream. Oh, I actually replicated some books from the proofs from the book today. You're right. We did. I did. Yeah, it went well. It was a good one. We definitely made some progress on these. We didn't quite make as much as I thought we were going to, but I'm really excited. I'm excited about what's going on here. We need to clean up some variable names. We need to. Hopefully, we'll get more powerful tactics eventually. Oh, what a day. Here we go, baby. All right, thanks for coming to the stream, everybody. I'll see everybody next week.